that is known as Floyd-Warshall algorithm. So this algorithm is actually is the problem of finding again a shortest path between all pair of vertices on a graph is keen to making a table of all the distance between all pair of cities on the road map. So this name is Floyd-Warshall algorithm. This algorithm is also for finding the shortest path between every pair of vertices. And all pair shortest path algorithm use a dynamic programming methodology to solve all pair of shortest path problem. It is used to recursively approach to find out the minimum distance between all nodes in the graph. And striking feature of this algorithm is its usages of in dynamic programming to avoid redundancy and thus solving the all pair of shortest path problem in that. So Discasca's algorithm have time complexity. If you can talk about the time complexity of the Discascal algorithm, then it is of order n cube. For Warsaw, and for Discascas it is of order n square. So the Discascal algorithm is very of sufficient means reliable other than the plots or Warsaw algorithm, because when you have a large data, this n is represent the number of vertices. So when you have a large data or large shape of graph, then Discastra's algorithm is preferable is to use. Okay, so let us understand what is this Warsaw algorithm is. So before that, you have to see what is the distance matrix in a graph. So for example, this is a graph you have. Let's say this one is the given graph with 5 vertices, and it's having the weight is, let's say this is 1 weight, this is 2 weight, this is 5 weight, this is 7 weight, and this one is 8 weight. And these are the vertices I'm denoting in this fashion 3, 4, 5. So you can prepare a distance matrix. This D stands for the distance matrix. And the distance matrix is, so it has 5 vertices. So I will just say it is 1, 2, 3, 4, and 5. And here it is also in the column, sorry, in the row also there are 5 columns, 5 rows and 5 columns is there. Now there is no weight is given from 1 to 1. So that's why it is 0 here. Since it is a simple graph, so all diagonal elements will have 0 because there is no loop. Now from 1 to 2, if I can say, this is undirected graph. Please note that this is undirected graph. That means you can go from 1 to 2 as well as 2 to 1. If I have put one direction, then you cannot travel reverse. Okay, so that is, this is an undirected graph is I have plotted. But the weight of this edge, that is 1 to 2, is 1. 1 to 3 it is 2. There is no edge between 1 to 4, so that's why it is 0. And there is no edge between 1 to 5, so that's why this is also 0. Now, if you can reach to 2 now, 2 to 1 we have 1, 2 to 2 is 0, 2 to 3 there is nothing, 2 to 4 it is 7, 2 to 5 it is 0. So in that manner, you have to fill all this data here. 3 to 1, 2, then it is 0. This is also 0. 3 to 4 it is 5, and 3 to 5 it is 0. 4 to 1, so this actually this column is copy, you should copy that one because you can have a reverse path also. So that says 4, 0, 7, 5, this is 0, and 4 to 5 will have 8. And this column will be come here. So this is a one special kind of matrix. If you can see the matrix algebra which you have studied in your previous semester, this is a special kind of matrix. Can somebody tell me what is this matrix is? Which you have studied in your matrix algebra course? Or I can say linear algebra in specifically. So this is actually a symmetric matrix.
Symmetric.
Okay, so this is a symmetric matrix. And this is D is stands for distance matrix. So whenever you have to start with this Floyd-Warshall algorithm, first you have to make this distance matrix. Another one is a node matrix. Node matrix is the from where you have visited, that I will discuss later on. But first you have to make this distance matrix, and you should know what is this distance matrix is. So let us see this algorithm, and these are the steps we have to follow. The step number 1, or I can say it is an initial step. So initially, what you have to do? Define the initial distance matrix. That I will say it is D0. Define initial distance matrix, that is D0. That I have defined for this graph in this manner. That is, we denoted as initially it is D0. So the 0 stands for iteration, how much iteration we are doing it. Okay. And initial node sequence matrix S, that we have denoted as S0. So that is initial node matrix as follows. That how to define this initial matrix. So the first one is the set all diagonal elements of D0 to 0. Since we are dealing with simple graph, or I can say there is no loop in the graph, the diagonals should be set at 0. That is, you can say that DII 0. That means DII means D11, D22. So that is this diagonal entries. D11, D22, D33, D44, and so on. All these entries will be 0 for all I running from 1 to n. So n is the number of vertices that we have pick up here. In second step you have to do, and also set all element of S0 to 0. So in S0 you have to put all of them are 0. That means I say that Sij 0 is 0 for all ij from 1 to n. So it is a square matrix, but all entry in that matrix is 0. So that is the initially we have to do this. Then the steps start for set k equal to 1. Set k, this is the initial step, that means I can say k equal to 0 step. This is k equal to 1. Now step k, what you have to do in the step k? Where k is between, so there are, how many steps will always have? It has always n steps in this k step. So first one is 0 steps, and then you will have n steps to follow this. If the condition dij k minus 1 is greater than dik k minus 1 plus dkj k minus 1 for ij running from 1 to n, provided this I is not equal to k, j is not equal to k, and I and j are not equal. So it is a situation like we have three vertices. The first vertex is I, the second one is j, and the third one is a k. So what will be the weight? Suppose we are traveling from this to this, so that is dij k minus 1 is this weight is there to traveling from here to here. This is the weight is there. Now to traveling from this one to this is dik minus 1, and from, so it is from I to k, and from k to j, so this is dkj k minus 1 is there. So this quantity is here and this quantity is here. If this is bigger than sum of these two, okay, so that is the situation is represented here. So in the figure, if you can see this correlate what we are talking about. Create decay. So we have to create a decay by replacing dij k minus 1 in dk minus 1 with dik k minus 1 plus dkj k minus 1. That means obviously if this portion is bigger than the sum of these two, then we have to replace the dij to this value. In the second step, create a node sequence matrix sk by replacing sij k minus 1 in sk minus 1. This s is a capital S and this s is a small s. This is also capital S with k. So we have to replace with k, whatever the step we are doing. Then set k equal to k plus 1. That means you have to go further and repeat step k until k equal to n. So after n step, what will happen? We will have our dn and sn, and in that will gives you your shortest path between every pair of vertices. So after n steps, we can determine a route between vertices I and j from the two matrices Dn and Sn using following manner or using following rule. In that A, from Dn we can compute Dijn gives the shortest distance vertices from I and j. So whatever the Dij is there in nth distance matrix, it gives you a shortest distance from I to j. And the B from Sn will contain a path, will gives you a path. Determine the intermediate vertex k equal to Sijn with which, while the root ikj, if k equal to 0, then stop. Otherwise, repeat the procedure between vertices I and k and vertices a and j. Okay, so that is the, I can say, algorithm that Warshall algorithm is there. Let's have one example. So the question is this: find or determine the shortest path or route from node 1 to 4 and from node 2 to 4 of the following network. Okay, so let's say this is the graph is given to us with 4 vertices. This is vertex 1, 2, 3 and 4. The edges is a directed edges. And they have given some weights here. So this is the graph, or I can say a network. So we have to apply this Warshall algorithm to find out what is the shortest path from 1 to 4 and 2 to 4. So first, in the initial step, this is my initial step, you have to write down what is D0. A D0 is a distance matrix which we have created earlier. And there are, so these are my nodes 1, 2, 3, 4. So first it says that in diagonally you have to set all of them as 0. Okay. Now there is a path from 1 to 2. Can we travel 1 to 2? Yes, with the weight is 8. And from 1 to 3 we can travel, but via some vertices. Okay, so we'll set some large number over that. If you are doing this one in computer programming, then you have to set this as a very large number. Here I am putting as infinity. So it is 1 to 3. There is a path is exists, but we don't know yet. So I am putting infinitive now. 1 to 4. If I want to travel 1 to 4, then it is 1. And 2 to 1 is infinitive because there is no path from 2 to 1. So reverse path is not exist. 2 to 3 is the path is 2 to 3 is there? Yes. The path is 1. So I will suggest that you can plot this figure in front of you, because every time I will not go back and maybe his computer will loading some data there, so it's may take time. So it's better that you have this graph in front of you, and you should do the whatever I'm doing here parallelly. 2 to 4. So there is no path from 2 to 4. You cannot go back. So, but there is some, maybe some path is there, but right now we don't know. So it is putting infinity. So it is very large number. 3 to 1. 3 to 1, it is a 4. 3 to 2. So there is no direct path from 3 to 2. So that's why it is infinitive. 3 to 4. 3 to 4 is also no direct path is there. So it is infinitive. 4 to 1. 4 to 1 is also no direct path. But 4 to 2 is there? Yes, 4 to 2 is 2. 4 to 3 is 9. So this is my distance matrix. And parallelly we have to create what is a node matrix. A node matrix initial step we have to put all of them are 0 here. So this is my node matrix. I will call this as vertices 1, 2, 3, 4. These are the 1, 2, 3, 4. Now, as per you can just read out the step number K. So in the step K, you have to check this condition, that is dij k minus 1. If it is greater than dik, if it is a via some node is there. So now each step, so now how many steps is there? So this is a step number K. For K start from 1 to, so K equal to 1. You start with K equal to 1. So now I'm taking the step 1. Okay, so in the step 1, what you have to do? You have to pick up a first vertex, that is n equal to 1 or k equal to 1. That we have to pick the first vertex. See, again it is taking time to do. So this is the step number 1. So in the step 1, you have to create D1. So that is this matrix with vertices 1, 2, 3, 4. Here it is also 1, 2, 3, 4. And S1 you have to create. Here there will be a vertices 1, 2, 3, 4, and on the column also. So you have to fix your first. So this entry is always 0 because it is a diagonal. So there is a path from 1 to 2, direct path is there. Okay. So you have to check. Is there any other path? So we are checking for 1 to 2. Is there any other path is there via 3? Is there any other path is via 3? So 1 to, you cannot go directly to 3. So there is no path from 1 to reach out to 3 through 3. It is not there. So this entry 1 to 2 stay as it is. This is infinitive. And 1 to 4.
Sir, there is a path to reach 2 from the 4.
Now intermediate is 1.
Okay.
Intermediate node is 1. Means the kth node, whatever the step we are following, the kth node, it is intermediate node. So that should be 1. So we have to reach through 1. So that is the target. That means so when we are taking the step number 1, the first row will not be changed. It will be same. Now from 2 to 1, can we travel 2 to 1 directly? No. Okay. So this will be infinitive. This is 0 because it is a diagonal. Now 2 to 3. When you travel 2 to 3, is the intermediate will be 1, that you have to check. So we have at 2, we have to travel 2 to 3, but that is a direct edge is there which is have 1, and there is no other path is there from traveling 2 to 3. No other path. Okay, because there is no outward directed edges is there from 2. So this is also 1. Now 2 to 4. We cannot travel 2 to 4 also. Is this we can travel? Yes. With intermediate is 1? No. Because when we can travel that one in that manner, but 2 to 3, then you can go, 3 to 1 you can go, and 3 to 1. But the 1 is not intermediate, 3 is intermediate in that sense. Okay, so this is also not changing. This will stay as it is. Now for 3 to 1, it is 4. So now we are at 3. 3 to 1, you can go at 4. Is there any other path to traveling? No. So it is 4. 3 to 2. Right now it is infinitive here. With
but
1.
We have path.
Yeah. So there is a path 3 to 1. Sorry, you have to travel from 3 to 2. Intermediate will be 1. So it is there. First you can go to 3 to 1 and then 1 to 2. So it is 4 plus 8. So it will be 12. Here it is infinitive. So 12 is a minimum. So that's why I will change this one, as I should make it with different color. This will be 0. Okay. And the next one is from 3 to 4 you have to reach via 1. So 3 to 4 we have to reach via 1. That is also possible. 3 to 1 we can go, and from 1 to 4. So that is 4 plus 1 will be 5. So here it is 12 and here it will be 5. So that is the things we got here. Here it will be 5 and here it is 12. I will change with some different color if it is load the things. Now what about the fourth one? 4 to 1, via 1 it is not possible. So this first column stay as it is. Then 4 to 2. 4 to 2 via 1 is not possible. So that stay as it is. This will be 4 to 3 via 1, not possible. So that is 9. And 4 to 4 is always 0. Here, what is the changes? The change you have made in this two position. See, this is taking too much time. Oh. So this will be 12 and this is 5. Okay. So the change is made at these places. This 12 we have changes due to 1 because we have visited 1. So that's why it is 1 here. And 1 at this place at here also. And all rest of them are 0. It is difficult. Now in the step number 2. Okay, so this is 1 here and 1 here. That is the change we have. And in step 2, we have D2. So in the D2, you just draw the matrix. Now I'll not write that 1, 2, 3, 4 here, 1, 2, 3, 4 here, and S2 will be the same 1, 2, 3, 4, 1, 2, 3, 4. Now intermediate will be 2. 1 to 1 is 0. 1 to 2. Intermediate is 2. So that is second column and second row will not be changed. 1, 2, 3. Via 2 if you can go. So what we have to travel 1 to 3 we have to travel via 2. Is it possible? Yes. 1 to 2 we can go and 2 to 3 is there. So the answer sum is 8 plus 1 is 9. Here it is infinitive. Here it will be infinitive. So this will be changed with 9. I'm not changing the color because it's taking a time. And why this changes occur at the step number 2 it will occur. So that is the value of k will be changed. This is 0. This will be 0. Will be there. Now what about 1 to 4? It is already 1 is there, but I think so that is no other path will be there. So 1 to 4 it is fine. So this is 0. 2 to 1. 2 to 1 intermediate is 2. So this will not be changed. Actually this stay as it is. The second column will be same. 3 to 1 via 2. So you have to travel 3 to 1 via 2. That is not possible. So it is as it is. 3 to 2 via 2. So that is also not changing. 3 to 3 0. 3 to 4 via 2. 3 to 4 we cannot go via 2. So that's stay as it is. 5. Fourth one 4 to 1 via 2. 4 to 1 via 2. Not possible, because we can go to 2, but from 2 to that is no path way is there. So it is infinite. Now 4 to 2 via 2, it's not changing, so it will be 2. Here it is 2. Now 4 to 3 via 2. 4 to 3 we can go via 2.
Possible.
Yes, yeah. 4 to 2 it is 2 plus 3, that is 2 plus 1 is there. So that's why it is 3. So this will be changed to 3, and so this one is 2 now. All other will be 0. Sorry, this one is 1. So this was a 1 we have in the previous one. That's why it is 1 here. And 4 to 4 it is 0. So that is also 0. So this is step number 2. Now step number 3, that is D3. So we have to again do the same thing. Now the intermediate will be 3. Okay. So we have to travel 1 to 1, that is 0. 1 to 2. 1 to 2 via 3. So we are at 1. Can we travel 2 via 3? No. So nothing is changed here. This will be 8, because previously it was 8. Now 1 2 3, we are at 3. So this third column I may write as it is, and third row is also same. So that's why I'm writing same. Only changes, and this is 0, this is also 0. So that is also not changing. Now 1 to 4 via 3, but it is 1, so that is also not need to change. 2 to 1 via 3. Right now it is infinitive. 2 to 1 via 3. Is that possible? Yes. We can go to 3, that is 1, and 3 to 1, that is 4. So 4 plus 1 is 5. Here it is infinitive. So this will change to 5. And parallelly, S3 is also changes. Here you will have 3. Okay. And the first one is stay as it is. Let's see what will happen here. 2 to 4, you have to calculate. Here it is infinitive via 3. So we have to travel 2 to 4 via 3. Is that path is possible? 2 to 4 via 3. Yes. 2 to 4 via 3. No, not possible.
Not possible, sir.
So this is the path. So 2 to 4, we have to travel from 2 to 4 via 3. We can go in this manner, and then this manner, and then this manner. That is the path is there. You can see from here to there. The 3 is intermediate, from there to there, and then from there. So it is 1 plus 4 plus 1, that is 6. So this will be 6. And this is via 3. It was infinitive here. Now 4 to 1 via 3. 4 to 1 via 3. It is there 9 plus 4. 4 to 1 via 3.
Sir,
Is
can
there
you
any
repeat
other?
this
Which?
third portion? 3 to 4.
3 to 4.
Yes, sir.
3 to 4. The thought, we are at a 3, so it is not changing. 2 to 4, I think so.
Okay, 2 to 4.
Yeah, 2 to 4 via 3. You have to travel via 3. So 2 to 4. So there is the path is there. 2 to 3, 3 to 1, and 1 to 4. Intermediate is 3 in that between. So 1, 4
1 is
plus.
also coming there, na? So is it okay?
Yeah, it is fine.
Okay.
So it is 4 plus 1 plus 1. So it is 6. So that's why it is changed to 6. Now 4 to 1 you have to find out the path. So tell me which path is there. 4 to 1 via 3.
4 to 3, 3 to 1. 9
13.
plus 4, 13.
So 13 is there. That is a one path is there. Is there any other? Four to three. See, we can travel in that manner also. 4 to 2. 2 to 3.
Okay, yes, and 3 to
And
1.
3 to 1. Okay. So what is that? 4 plus 1 plus 4. That is 7. So 7 is the minimum. Is there any other than this? Check. I think so 7 is the things we got here. So 7 and this value will be changed due to 3. Now 4 to 2 we have to travel via 3. 4 to 2 via 3.
Yes, sir, it's possible.
Which one? That is
4
9.
to 3, 3 to 1, and 1 to 2.
Okay, but 9 plus 4 plus 8. So
Yes.
12 plus 21. Here it was 2. In the D2 it is 2. So that 2 is the minimum one. So we will not change that. Stay as it is. Okay. So that is the quantity. We'll have this. Now step number 4. D4. So into the D4 we'll have 1, 2, 3, 4. This is 1, 2, 3, 4. The 4th row and 4th column will not be changed. So that's I'm just copying from the above. And this diagonal entries also will be not changed. 1 to 2 via 4. You have to find the path from 1 to 2. 1 to 2 via 4. So it is possible, yes. 1 to 4 and 4 to 2. So 1 plus 2, that will be 3. Here it is 8. The weight is here 8. So it is changed to 3. And similarly S4 is also changing here. That is 0 and this due to 4. We can have this. Now 1 to 3 via 4. 1 to 3. You have to find out the path from 1 to 3 via 4.
That
So
will be 10.
that is 10. But 10 here it is 9. Okay, here it is 9. So that's 9 stay as it is. And nothing will change here. Now 2 to 1 via 4. 2 to 1. 2 to 1 via 4. So I think so that path is possible. Not possible. We can go to 3, 3 to 1, but we have to travel 2 to 4. So 3 to 1, we have to travel 2 to 1. So we'll start with 2 via 4, 2 to 1. I think so that path is not possible. So that is 5 stay as it is. 2 to 3 via 4, 2 to 3. So we can just travel 2 to 3. Still it is not showing. 2 to 3. Is that possible? 2 to 3 via 4?
No.
No possible. So that stay as it is. 1. So this third and this one is stay as it is. Now 3 to 1. 3 to 1 via 4. 3 to 1 via 4. Is that possible? No, because there is only one outward is there, that is 3 to 1, which has, and if you add anything, will be more than 4. So that's why it is stay as it is with 4. Here it is 12. Now 4 to 2 via 4.
7.
So 4 to 2.
3 to 2, sir.
Sorry, 3 to 2 via 4. So that is a path is 3 to 2 via 4. So that means you can go to 1, then 1 to 4, and 4 to 2. So it is 1 plus 4 plus 2, that is 6. Please check in your notebook if you have drawn this figure. The path is possible 3 to 1, then 1 to 4, and 4 to 2. So it is 4 plus 1 plus 2, it is 7. Here it is 12. Okay, so that 12 will change to 7. And this change is made due to the 4th vertices. And this is what was previously, it is 0. This will be 0, this is 1, and the last one is obviously stay as it is. So this we have to stop here, okay, because we have n is equal to 4, that is number of vertices are 4. If the number of vertices, any of the number of vertices is there, that one is your number of steps should be in this algorithm. And what was the question? Question was to find out the path between 1 to 4. What is the minimum cost traveling from 1 to 4? So the minimum cost is traveling from 1 to 4 is 1.
1.
Okay, 1. And what is the vertex? That means it is a directly path is there from 1 to 4, because how we can know that? Because here this entry is 0. So the path will be directly 1 to 4. That is, we can conclude from this. The second question was to calculate the path from 2 to 4. So the weight from 2 to 4 is 6. Okay, so traveling from 2 to 4, the weight for the 2 to 4 is 6. That we can say. But what will be the path? To find out the path, you can just see what is the corresponding entry. That is, the third entry is there. Okay, so the intermediate entry. So it is a 6 unit that we can show. So associated path, we determine the intermediate node. Intermediate node, that is k equal to 3 here. That is k is equal to S24 at 4 is 3. So in between 2 to 4, that is a node 3 is there. And the route that we have is 2, 3, 4. Now we have to find out whether 2 to 3, that means S23 at 0, sorry, at 4, is there any value is there? If it is there, is there any value in between these two, then that value will become here. But what is S23? This is 1, 2, 3, 4. This is 1, 2, 3, 4. S23 is this entry, 0. So this is 0. So there is no intermediate vertices in between these two. Okay, so this is, and what about 3, 4? Is there any intermediate vertices between 3 and 4? So for that you have to check 3, 4 at 0, sorry, at 4. So what is 3, 4?
0. 1, 1.
3, 4 is 1. So in between 3, 4, there is a one vertex is there, which is 1. So this is, I think so, the path is there. Now you have to check again. What about S23 at 4? S23 is, you can say it is 0. S31 at 4. S31 is 0. And S14 at 0. S14 is also 0. So there is no other intermediate vertices in between this. So this is your path. To travel from 2 to 4, the path is 2 to 3, 3 to 1, and 1 to 4. You can check, it will be 6. And that is your minimum path will be there. Okay. Can I give you one example as an exercise to do? So this is the graph. You try for, see this, I'm plotting, this is the not directed edges. So you can go via both the ways. Okay. And this is the fifth one. This is only one edge which is directed. So this is 3, this will be 10, this is 5, this is 6, 4, and 15. So this is the graph. You can find out a path traveling from 1 to 5. Okay. So I think so you can able to do this example by your own. If not, we'll do
4
it
to
next
5
lecture.
is directed. Hello. Sir, 4 to 5 is directed or not directed?
4 to 5. 4 to 5 is not direct. Only one directed graphic edge is there. But that is 3 to 5. No other.
So, sir, other direction we have to decide by our own?
No, it's both the way. That means you can travel from 1 to 2 and 2 to 1.
Okay.
Both way. Fine. Try for this example and we'll solve this one in the next lecture. Okay. Hope you can do this.
Okay, thank you, sir.